Problem number 2, perform the indicated operation, dividing here. Write the answer in the form a plus bi. So these are complex numbers. Complex number division of complex numbers, essentially. The main idea here is this this imaginary number, this complex number, we don't want that in our denominator. Just as if we had a radical in the denominator, we would have to rationalize. Here, we have to eliminate this imaginary number here in my denominator. And we use the same approach as we would if we had a radical in that denominator. That approach, multiply by the complex conjugate of the denominator. Complex conjugate. So I have negative 8 plus 3i divided by 5 plus 7i. So the denominator is 5 plus 7i. The conjugate of that is 5 minus 7i. And that's what I multiply by in both numerator and denominator. It's like I'm multiplying by 1. I'm not changing the value of the overall rational expression, the overall fraction. Multiply, we can distribute here. Negative 8 times 5 is negative 40. Negative 8 times negative 7i is positive 56i. 3i times 5 is 15i. 3i times negative 7i is negative 21i squared. That's my numerator. Now what you might remember is when we're multiplying conjugates, complex conjugates better yet, something special happens. A plus bi times a minus bi becomes a squared plus b squared. Do you remember that relationship there? So 5 plus 7i times 5 minus 7i should become 5 squared plus 7 squared, 25 plus 49. I'll do it on the side here. I'm still going to multiply it out just in case we don't remember this relationship. So 5 squared plus 7 squared. It's plus because that I squared becomes negative 1, multiplies by negative 49, etc. So 25 plus 49, that's 74. That's going to be my denominator. Let's multiply it out. 5 times 5 is 25. 5 times negative 7i is negative 35i. 7i times 5 is plus 35i. 7i times negative 7i is negative 49i squared. Combining my like terms in the numerator, negative 40 plus, what's that? 71i, right? 56 and 15, yeah. Minus 21, I squared. Remember, I squared is equal to negative 1. You have to replace your I squared with negative 1. Got to do it. My denominator, I have 25. Negative 35i plus 35i is 0. Minus 49 times, you guessed it, I squared, which is negative 1. Okay, still working here. So I have negative 40 plus 71i plus 21, because negative 21 times negative 1 is positive 21. In my denominator, I have 25 plus 49, which is exactly what you would have if you used this kind of shortcut here. Negative 40 plus 21, that's negative 19 plus 71i over 74. Now you might stop here and say, yeah, I'm done. I've gotten everything. I can't simplify anymore. Everything's nice. But if you look back at the prompt, write your answer in the form a plus bi. We need that standard form. That standard form for a complex number. The real part, imaginary part. I can't tell what a is here and what b is here, so I need to show it. I need to split this. So I've got negative 19 over 74 over that denominator plus 71 over 74i. Now I'm in A plus BI form. I can clearly see the real part is negative 19 over 74. The imaginary part is 71 over 74i. Now we're done. If you could have simplified or reduced this fraction, either of these fractions, you need to do that as well. But we can't in this instance.